Earlier in this course, we built an HTTP server capable of serving web files over HTTP. We had to handle file requests for each type of file and respond with the appropriate headers and content. It was a tedious task to build a file server with the core HTTP module, but we know it can be done. We know how to do it. However, when it comes time to get your work done, we can rely on the NPM community. There are a number of file servers that can serve static files over HTTP. What we have here, inside of our start file, we have a folder called client. It looks like the front-end team delivered a client web application that's ready to go. If we want to take a look at these files, we need to serve them over HTTP with a web server. So there's actually a module that can help us do this. Now, one way that we can run certain types of packages is we can run a command called npx. This is Node.js's and npm's file runner, and we're going to run a project called serve. And what serve is going to take in is whatever the location of these client files is, which is /client. Serve allows us to select a file folder and serve it over HTTP. So now this is telling us that we have this running on localhost 3000. If we go to localhost 3000 in the browser, we should see our client template for our dictionary. In the remaining videos in this section, we're going to take a look at how we can actually make this application work by working with some methods that are part of HTTP. The serve module allows us to serve static content, but that's just one option. In order to complete the task of building the Ski Dictionary web application, we're going to need some more control. We will use Express to help us build and customize a web app that serves files and handles definitions over our REST API. So what we want to do first, aside from making sure we're in the right folder, is our project it has this client folder, but we also need a package JSON. If we don't care too much about configuring these options, we can run an npm init-y. This is going to initialize our project with all of the defaults. So we have start, version, all of those things. You can always go in here and change this. I could call this Ski Dictionary. We could customize anything else we wanted to. The next thing we'll do is we'll run npm install express to install our express dependency. This is going to install this into the project. The next thing we want to do, at the same level as the client folder and the package JSON and all this other stuff, we want to create a file called server.js. Now, server.js, we could go back into the package JSON and correct this to be our main file. We also want to make sure that we're using the type module so that we can use those imports. So let's go to our server next, and we're going to import Express from Express. Express is one of the most popular NPM libraries to use. It helps us build websites and APIs quickly by taking care of a lot of the monotonous tasks that are necessary to handle every single edge case when building a server. Express is also completely extendable and customizable, so we can build a bunch of different types of web apps using it. So we've imported this, then we're going to create an instance of our app by calling the Express function. Then we're going to call app.use. We're going to go to the home route. We're going to stand up our server. So we'll say Express static. Let's serve up our ./client folder. Next, we're going to call app.listen. We will send 3000 and we'll say console log the Ski Dictionary running at 3000. Cool. Now we can run our project running node server, and we should see our dictionary running again. But if we take a look at the console, we might see an error that is trying to look for these definitions at /dictionary, but it cannot get this. So we need to use Express to serve up these definitions. First, we're going to need some definitions. So we'll say ski terms.json. And let's go ahead and define these ski terms. So term 1, we'll say the term is hook. And this one defined means to send your body off a cliff. Then we're going to use the term rip And this one is defined as to ski at a high rate of speed. Perfect. So now what I can do, if I go back to our server, is we can import this. So we'll import ski terms. Okay, so now that we've done this, we need to add one other thing here. We need to add assert type JSON. So what we're doing here is we're importing this file, but in order to make this work, in order to make sure that our file is recognized, we're using kind of this experimental syntax here. So we need to go ahead and say, this is the type of the file that we're importing. You probably won't always have to do this, but this is, if you see an error that says that you need to define a type, this is how you would do so. The next thing we want to do is underneath app.use, we're going to call app.get. And here we're going to use dictionary as our route. And we're going to add a callback function here saying request response. And then we'll say response.json ski terms. Now I want to stop this, Control C. I will call node server once more. This is giving us this experimental warning, which we understand. But the more exciting part here is if we go back to localhost 3000 and we hit a refresh, we see that our error has been cleared. We also see that this information is being displayed. So now if we go to the dictionary route /dictionary, all of our JSON raw data. So if we fill out this form and click add term, we're going to notice that there's another error. So it's saying that it failed to load a resource and that we are failing to fetch. So let's take a look at the request with the Chrome browser tools here. If we go to the network tab, we're seeing that we're failing to load a resource. Remember that these HTTP requests are readable streams. So instead of handling the data ourselves, we can use an NPM called the body parser here to do the heavy lifting. So let's install body parser. And we're going to add a post route to our application. So we're going to say import body parser from body parser. And then we'll import fs from fs. Once we've done this, we can call app.post, and we're posting this to the /dictionary route. And here we're going to use as the second argument to post body parser. There's a function called .json that's going to parse this as JSON. And then we need to add a callback function to say what we want to do. So we're going to say request and response ski terms .push. We're going to push whatever those terms are into the request body. And then we'll call response.json. Then we'll pass along the status of success. And the term is whatever is in the request.body. So every time a new term is added, we can save it to a local file in our system. Obviously, we would probably save data like this to a database, but this tiny app doesn't have one, so the file system will have to do. Let's go ahead and create a save function to make this work. So we'll say const save, and this is going to use from the file system module. We'll say fs.write file, and we're going to write this to data/ski terms.json. We will json.stringify this ski terms null and 2. And then we'll pass along a function to handle any errors. So we'll say if there's an error, throw the error. And then finally, we want to add this function. We'll call it save. Let's go ahead and try to run this once more. We will go back to our localhost 3000. This time we'll say send to jump off of something. A lot of skiing is just jumping, right? And when we add that term, we're going to add it to the page. Now we can add new terms through the client. The client uses HTTP to send the data, and we can capture that data and do whatever we want with it. One quick thing I'm noticing too is that we're getting no such file or directory with our write file, and that's just because I don't have it in a folder called data. I messed up. So we'll go back and try that again. And we need to refresh and we'll say send to jump off of something big. Add the term, we see it there. If we go to our file, we see it's added to that list. All right, there we go. We're writing to files. We are displaying that data in our UI. Our skier dictionary is really starting to come together. There's one last thing to do. If we go to the network tab and then we click on the trash can icon next to one of these terms and then we say OK, we're noticing that there's a 404 error here. There's some sort of a problem, cannot delete dictionary/hook. Our client is trying to send a delete request to our API, and the term that the client wants to delete is being described by the route itself, /dictionary/hook. So no problem. Express automatically handles routing parameters for us, which makes it easier to capture and use this data. So let's go ahead and add a delete route to our API. All right, so we want to call app.delete. We're going to use dictionary / and then we'll use a parameter here. We know it's a parameter because we use the colon. So whatever that term is, hook, drop, whatever. So that'll take the place of that term. Then we want to call a callback function, request and response, and we'll call ski terms.filter. This is going to check to make sure that our term does not match whatever the request params dot term is. In other words, what we're saying here is if the term isn't being deleted, let's keep it in the list. We will call the save function again, and then we'll call response.json and use the status. We'll say removed is whatever the request params dot term is. And then finally, we'll set a new length, which is whatever the length of the new array is after that term has been removed. So let's go ahead and stop that. We will start it again with node server. We'll go back to our page and we'll make sure that we're refreshing. Now let's delete hook. Okay. And it's looking like ski terms.length. Typos are our best friend. Let's delete hook again, and it's working. We see a 200 code. So we're noticing this error about assignment to a constant variable, and that's because when we're importing this, it's assuming that ski terms is a constant. We can use let definitions equal ski terms. We'll replace the variable everywhere it's used. So definitions, 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 definitions. Nice. So we have worked around that issue. We should be able to click on the trash can icons and make all of that work as we want. Our application is complete. It reads and displays a ski dictionary, and it allows users to add terms. We can use Express to create as many routes as we'd like, but sometimes we want to insert some functionality before every request. So Express uses this pattern called middleware to allow us to accomplish this. And believe it or not, you've already been using it. So let's take a look. So first things first, we want to add another one of these app.use functions. We're going to call body parser.json. Then we're going to call app.use, and this time we're going to pass in a callback function here. Zoom in a little bit. So our callback function is going to take in the request, the response, and then a function called next. More on that in just a second. So we'll say console.log request.method is a request for request.url. Then we'll say if object.keys request.body.length. So if there are any more values left in that request body, we want to console log them. If not, we'll jump out of the loop. Then we're going to call .next. So next is basically just going to move on to the next value that is part of that request object until we're out. We're going to make sure that we're in the right folder first, of course. Then we're going to run npm install to install our dependencies. And then we'll run node server. Node server fires this up on localhost 3000. And now if I start to post these things or delete a few different items, we're going to see that all of this is being logged right here. So we're getting a little bit of detail about exactly what's going on the app. So this is pretty cool. We've been able to use middleware to log a little bit of extra detail about the request. Express supports this pattern, and we can use it for all sorts of different things. WebSockets allow for a true two-way connection between the client and the server. Clients connect to a socket server, and the connection remains open until a client disconnects. And while that connection is open, data can be passed to and from the server. Again, it looks like our front-end team has delivered the files to us inside of this client application, and all of these files should run in the browser. So let's make sure that we're in the start file, and we're going to run that same command. But this time, we want to also supply a flag where we're going to run this on port 5000. So we can go ahead and pass that along. It's going to run this on port 5000. And if we go back to our browser, localhost 5000, it should bring up our chat application. So if we take a look at our browser console, it's saying WebSocket connection to WS localhost 3000 has failed. So it's trying to connect to this WebSocket, but that's not available. So we're going to install a package that's going to help us construct a simple WebSocket. We'll run npm I ws. This is going to install that for us, and then we can start to use it inside of our server file. The first thing we'll import is WebSocket server from ws. And then we're going to say const wss is a new WebSocket server that's running on port 3000. Next, we're going to manage this connection using ws.on. The event we're listening for is that connection, and we'll pass in a callback function here. Now our callback function will say console log. So inside of this console log, we'll say new socket connected. We're also going to manage our disconnections here. So we'll say ws.on close, and here we will say console log user disconnected. And then finally, outside of this, we're going to add a general message, console log chat server waiting for connections on WS localhost 3000. And then I'm also noticing that I need to use the right variable name. We'll say wss.on. And then we're going to also pass in WS as the value here. So make that quick tweak, WSS, and then WS refers to the WebSocket inside of this context. All right, cool. So what we want to do here is we want to have two different terminals running, one for our client, one for our server. So we can hit the split terminal icon. We're going to type npx serve./client, and then we'll pass the port as the flag here with port 5000. So that'll get running over there. And then we'll also run node server in the other terminal. And our chat server will be waiting for connections there. So now if we hit refresh, we're connected. We no longer see that error. And now we can say hello. And while we're not capturing those just yet, it'll say new server is connected. If I open another browser window to localhost 5000, we're going to see that new socket connected. If I close one, we'll see that this is disconnected. It's important to remember that WebSocket connections remain open until they disconnect. In the next lesson, we'll learn to pass data between the client and the server using these WebSockets. In the last lesson, we started building the socket server for a browser-based chat application. Now, the front-end team, as we saw, had delivered this client folder that had a bunch of static assets in it that we needed to set up a server behind. So let's go ahead and start that client. We're going to do so with npx serve We'll use /client for the name of the directory, and then we'll also pass a port with the -p flag so that this will run on localhost 5000. So now if we go back to our application, localhost 5000 doesn't have a server. We need to run our server with node server. Now, if we hit refresh, we should see that a new socket has been connected, and this will occur for any other tab that I open up. So notice that when I start to type messages, those are not captured anywhere. Nothing is happening. So what we want to do next is we want to create a new array of messages that we can populate. And we're also going to react to this on method every time there's a new message. So we'll say message, we will console.log that message, we will call messages.push, and we'll push each one of those messages in. I want to make sure that that message is being captured as a string. So we'll say message.toString. We'll also say if message.toString equals exit. So if the user types exit into the terminal, then we'll call ws.close. We'll call wss clients for each. So this is going to iterate through all of the clients that are connected, all the browser windows that are connected, and we're going to send that message to each one. So we'll say message.toString. Awesome. Let's also do this. We're going to call ws.send. We'll say welcome to live chat. And then we'll say if messages.length. So if there's any sort of length to that, we'll call ws.send. Chat currently in session. And we'll call messages.forEach. Message ws.send. Message.toString. Cool. Let's try running all of this again. We'll run npx serve, all of that good stuff. We are also going to stop and restart our server. Now, if I hit refresh, we should see all of these messages being displayed. If I go back, we're seeing this buffer. So what we need to do to see those messages logged here is call toString on the message. So let's stop that and restart it. And then it's actually working now. So we want to make sure that we have two of these side by side. We'll see localhost 5000. This time we'll say hey from this window. We'll see it pop up here. I'll say window on the right says hello, and that should pop up over here. Now we've built a chat application using the basic WebSocket spec, but this spec has some limitations. In the next section, we'll learn to use a popular library for building Socket applications, SocketIO. In the last lesson, we created a WebSocket and connected to it using the native WebSocket object in the browser. Native WebSockets are really cool, but there are some edge cases that a native WebSocket cannot handle on its own. If we want our apps to work in 100% of the browsers, we need to have a solution that can still work if WebSockets aren't supported. SocketIO is a WebSocket framework that falls back to different data polling techniques in environments that don't support WebSockets. So what this means is that you can build a real-time app that's supported in every browser. So let's start to build our server using SocketIO. We're going to install socket.io into our project. And then I'm just going to replace everything that's part of this file. I'm going to delete it all and replace it with a server. So we're going to go ahead and pull create server from the HTTP module. Then we're going to import a function called server that comes from socket.io. Then we're going to stand up an HTTP server. So we'll say create server, and we'll call .listen on our 3000 port. Next, we will create a variable called IO that's set equal to a new server constructor that will pass our HTTP server to. Then we need to handle connections. So we'll say whenever there's a connection, We want to take the information about the socket and we want to console log. So this will let us know how many clients are currently connected to our server. Then we're going to call socket.on. So whenever a new message comes in, we'll say message. Here we'll console log, whatever that socket ID is. So what that refers to is whatever the number of the connection is. So if we're all connected to the same chat application, each one of us would have our own client ID. Then we're going to call io.sockets.emit. We'll borrow from that event emitter pattern. And every time we have a message, we're going to emit an event with the message and the socket ID. So what do we want to have happen when a disconnect happens? Let's keep it simple and just console log that something has been disconnected, and we'll also grab the socket ID. So let's go ahead and console log socket server here. Socket server will just let us know that this is that particular app. Okay, so we've built our server. The next thing that we want to do is we need to create a lightweight client for our socket server, just so that we can test it. Our front-end team has not delivered a chat implementation with SocketIO. It doesn't really matter because the scope of WebSockets goes way beyond the browser. Any type of client can connect to a WebSocket to send and receive data. So instead of our browser app, we're going to build a little CLI, a command line interface application that will allow us to communicate with our socket server via the terminal. So let's go ahead and install a separate package called socket.io-client. We use this when we want to consume some data. So inside of this file, we're going to import a function called io from the socket.io client package. Then we're going to create a variable called socket that's going to set up our listener. So we'll say HTTP local host 3000. Then we'll call socket.on connect, and we'll say console log SocketIO client is connected. All right, great. So let's go ahead and run our server. That's running the socket server. We're also going to run with node socket client. It'll say socket client is connected, and then it'll let us know that one connection has happened. And then let's also do it again. We'll say node socket client, and then we have two connections there. There are all types of clients that we can build that will allow people to chat over this socket. This means that people can chat from the terminal or the browser or a phone application and all communicate via the same server. Another benefit of using SocketIO is its ability to raise events by name. The WebSocket spec only handles message events, so that means that all types of data has to be served through the same event. It would take us a lot of code to separate different chat environments and push many different types of data using only one event. So let's handle these different events. So in the previous lesson, we created the emit event where we're passing in the name of the event called message. So the way that I can deal with this on the client is I can say socket.on message. We'll take in the message and the ID, and we'll console log the ID and the message. Next, we want to say process.standardinput.on. So anytime we get some new data, in other words, anytime I collect information from the terminal, from our user, we want to take that data and we want to call socket.emit. We want to emit the chat event and use data.toString.trim to trim off any extra white space. Back to our terminal, have two different sides here. The first is our server, so we'll node the server. The second is our client, so we'll say socket client. We'll notice that our one connection is made. If we say hey, this will give us our client ID and the message. So if I was to open up a new one, we'll run node socket client, two connections over in the server. So if we say hello from client 2, it'll give us a different ID, but also the message. This is only a brief introduction to all of the things that are possible with WebSockets. Real-time applications are the future of the internet, and Node.js, of course, supports them.